Here we have to use partial fraction decomposition to break apart the given fraction into its smallest possible fractions. We are going to do that by setting this equal to the fractions that have each part of the least common denominator represented in them. These fractions are going to have the possible denominators x minus 2, but then also x minus 2 squared to represent both possible denominators coming from x minus 2 squared. And the last one will be the denominator representing the possibility of x plus 5. Since each of these denominators has a linear denominator, not including multiplicities, then that means their numerators have to be 1 degree less. The only thing less than a linear function is a constant. So all of our numerators have to be constants. Okay, to solve for A, B, and C, we're going to clear fractions by multiplying every single thing we have on both sides of this equation by our common denominator, x minus 2 squared times x plus 5. When we do that, what we're going to be left with is just the x squared on the left-hand side. The first fraction with the a in the top will have one of the x minus 2's cancelable, but not the other one. And we'll also have an x plus 5. The middle fraction with the b in the top will have the x minus 2's both cancel, but have an x plus 5 left over. And the last fraction with the c, the x plus 5 is going to cancel, but both of our x minus 2's will be left. Okay. There are lots of different ways to solve these for A, B, and C. I'll show you my favorite. One of the quickest ways to solve for A, B, and C is to pick x values and plug them into this equation. But by picking x values and using a little bit of foresight, we can make things really easy on ourselves. Two really good x values to pick are x equals 2, and then a little bit later on, x equals negative 5. Watch what happens when we choose x equals 2. When we plug in x equals 2, we're going to get 2 squared for x squared. So 2 squared is 4. And here's the great thing that happens. A times 2 minus 2 and 2 plus 5. The 2 minus 2 will totally cancel away to 0. So this whole term turns into a 0. For the middle term, we're going to have b and 2 plus 5. And that will turn into 2 plus 5 is 7 and b. And the last term, we have plus c and 2 minus 2 quantity squared. This also turns into 0, just like the last one did, so plus 0. So we have 4 equals 7b. So b is equal to 4 divided by 7. Great, that tells us one of our numbers. Now the second number I'm going to plug in on the next page is x is equal to negative 5. In the same way that x equals 2 made this set of parentheses and this set of parentheses cancel away to 0, the x equals negative 5 should make anything with an x plus 5 go to 0. So let's go to the next one, make sure I remember what I've got here. Now I have the equation x squared equals a times x minus 2 x plus 5 plus b, we knew, I'm going to plug it in because I have forgotten what b is. b was times x plus 5, and then plus c times the quantity x minus 2 all squared. And remember, in this case, we're plugging in x equals negative 5. Okay, when we plug in x equals negative 5 into that gigantic equation, we're going to get negative 5 squared is 25 equals a times the quantity negative 5 minus 2 and negative 5 plus 5 plus b times the quantity negative 5 plus 5 and plus c times the quantity negative 5 minus 2 squared. Just about finished with this one. Negative 5 plus 5, as we wanted, goes to 0, and also here too. So we have the equation 25 equals, let's see, c times negative 7 squared, so that's 49. 25 equals 49c. So c is equal to 25 divided by 49. Okay, so if I go back to this page, see, b was equal to 4/7. So I have c equals 25 over 49, b equals 4/7. Now all I have left to do is solve for a. Now unfortunately, looking at my equation up here, a has both an x minus 2 and an x plus 5 in here. So that means that if I plug in the negative 5, this will cancel, and if I plugged in the x equals 2, it will also cancel. So let's put all of this together. I'm going to give myself some room here. And let's plug in the next best number, which is going to be x equals 0. While at the same time plugging in the two numbers we do know. B is equal to 4/7 and c is equal to 25 over 49. So that's going to give us 0 squared is 0 equals a, 0 minus 2 is negative 2, 0 plus 5 is 5, plus b was 4/7, 0 plus 5 is 5, and c is 25 over 49, which does not want to draw my 9. And let's see, negative 2 squared will be 4. All right, this is 0 equals negative 10a plus 20 over 7 plus 100 over 49. All right, and the last thing to do is isolate the a and get a common denominator. So let's see, if we multiply this by 7 over 7 to have a common denominator of 49, that's going to be 140. And if we move the 10a to the other side, we have 10a equals 240 divided by 49. And dividing both sides by 10 gives us a is equal to 24 divided by 49. Fabulous. Now, all we need to do is plug in a, b, and c into our original equation. So a was over x minus 2, b was over x minus 2 squared, and c was over x plus 5. So that should give us, I'm never going to remember this, that should give us, let's see, a over x minus 2, b over x minus 2 squared, and c over x plus 5 will give us 24 over 49 over x minus 2. Let me stall to figure out what b and c were. If I remember right, c was 4 over 7, and it feels like b was 25 over 49. Let me go back and double check that. b 25, oh, I got those two mixed up. 4/7 and C was 2049. So let's swap those guys out. This was 25/49. And this was 4/7. And we are done.